y'all, it's Miss Flores. So today we're going to be talking about weather and climate and the differences between them. Well, a lot of times when we hear about weather and climate or climate change and things like that, we think about them being the same thing, but there actually are a few differences in them. First off, our weather includes the day to day conditions in the atmosphere. The conditions are short term and can change by the minute or the hour. So sometimes when we look outside, right, we can see like it's sunny, it looks great, and then an hour later, all of a sudden, there's a thunderstorm. That is a change in weather. Our climate, on the other hand, refers to a long term pattern of weather, usually over at least 30 years. So if we're talking about the climate of Corpus Christi, right, we're used to it being pretty hot, pretty humid because we're close to the water, right? And that would be our climate because it's like that most of the time. If it is hot and raining outside, you might describe the weather as rainy, warm, and humid. If your location has experienced rainy, warm, humid weather most days for 3 decades, that's 30 years, you might describe your climate as tropical. So when we're thinking about weather and climate, think about that winter storm we just had, right? The climate of Corpus Christi is normally pretty warm, right? We don't have snow, we don't really have ice, we don't have those kind of problems because our climate is more tropical than that. But our weather did change based on that storm, but that isn't describing our overall climate. So let's watch this video real quick.
How would you describe the winter this year? Normal, icky, or super icky?
Super icky.
Super icky.
Mm-hmm.
All right, thank you. It was a most unscientific survey, asking the most obvious question.
Super icky.
Super icky. All right, thank you.
You're welcome.
But the sun was out, the temperature hovered near 50 degrees. It was the first mild day the folks in Asheville had experienced in months. And so it was the perfect day to pose the question on everybody's mind. How would you describe the winter this year? Normal, icky, or super icky?
What is icky, though?
You're an icky? Okay. How about you?
Super icky.
Super icky.
Too much snow.
All right. What about you, sir?
I'd say normal, but I'm from Pennsylvania.
The gentleman from the Keystone State was the exception. It's not surprising that labeling the past winter super icky won hands down in my survey, which I conducted near the National Oceanic and Atmospheric Administration's National Climatic Data Center. The folks inside know a thing or two about the weather, so just what kind of winter was it?
The thing about this winter is really unusual compared to recent winters. When you compare it only to the 21st century winters, it was really cold in the east and it was really snowy in the east. But when you extend that record backward and you start looking at the late 20th century and the middle 20th century, this winter doesn't seem so unusual. We've experienced several winters like this in the past.
It seems we have short-term weather memories. The past winter was unusual, no doubt, but not all that unusual when you look back over 30 to 40 years of weather data. The scientists at the center also say the fact that most everyone thought this winter's weather was so unusual is proof. We are getting used to shorter, warmer winters, which come with a slowly warming world.
It's a key thing to note. Winters are changing in the U.S. and around the northern hemisphere, and we don't experience this type of winter as often as we used to.
As the world gets warmer, the long-term climate trend is for winters to be warmer and shorter, and summers to be hotter and last longer. But climate scientists note the daily weather can still change.
But what we have to deal with every day is the weather. And the weather still moves hot and cold air around like it used to before the world was warming. And so understanding what's the relationship between the ingredients that drive today's weather and climate, and the relationship is how often do those ingredients come together now?
Think of it this way. The man walking his dog represents all of us. The dog is the day-to-day weather. The incline is the world's temperature, and the hill represents climate. As our everyman and his dog progress through a world in which the temperature is gradually rising and the climate warming, the dog still moves around. The daily weather still changes. Everything is still warming, but the weather goes back and forth. In short, climate determines what clothes are in your closet and whether you buy a certain coat. Climate is long term. Weather determines tactical decisions, such as what coat you will wear on a particular day. But let's go back to our recent winter. Scientists call it an exception. So, what type of weather can we expect to see? In general, the climate trend is for winters to be warmer and shorter, while summers will be longer and warmer. Scientists say rain and snow events will be different as well.
The big change for precipitation is not so much how much precipitation a place is going to be getting, but how the mix will change over time. That what we're seeing currently, and we're seeing it around the world, an increase in heavy precipitation, and that goes very much along with climate theory, that your clothes dryer warms the air in the dryer because it can evaporate the water more quickly because warm air can hold more water vapor. So when you have a warmer air, you have a potential for the air to hold more water vapor. So when something does trigger a storm, such as a cold front coming through, there's a greater chance that it's going to have more water vapor in the air and therefore a heavier precipitation event.
Bottom line, scientists say areas won't get more rain or more rain events, but the amount of rain that falls per event will be heavier. A warmer world will also bring more heat events, such as extreme droughts and fewer cold events. The warmer, wetter atmosphere could also generate more severe storms. All of this climate projection is based on an analysis of massive amounts of data. The Asheville Climate Center collects almost 4 petabytes, or 1 million gigabytes of weather data per year. It's collected from weather stations and airports, weather observers, and satellites. It's enough information to fill 20 million 4-drawer filing cabinets per year. It's all available to the public, and scientists hope people will use the information in planning for a changing climate.
Because we have to know where we are to know where we're going in terms of weather and climate. So we get a baseline of conditions each year, and then we look to the future with the benefit of models.
Adaptation to climate change also adapts us better to our current environment. And adapting to our current environment adapts us better to climate change. I mean, this is a change that impacts things because our ecosystems and our cities and our built environment are all designed for the climate of the recent past, not the climate we're moving into.
All right. Now, let's explain the model in the video of the man walking his dog up the hill. So our dog in the video represented our weather. The incline representing the world's, the incline of the hill represents the world's temperature. The hill represents our climate. They represent our overall climate. As they climbed the hill, the dog representing the weather was moving around, right? Our day-to-day temperature and weather changes every single day, right? So even though everything was still warming, because our hill kept on increasing, right? Our climate was increasing, the weather goes back and forth. So just because we're experiencing climate change and the overall temperature is increasing, that doesn't necessarily mean that we see that big of an increase in our day-to-day weather. Let's look at slide 25. So here we've got our drag and drop that we're going to complete our organizer with, explaining the differences between weather and climate. All right, so change that can happen within minutes or hours. That's going to be weather. That is going to be weather. And average weather occurring over decades and centuries is going to be climate. Short-term conditions in the atmosphere are weather. So how we might have experienced that winter storm, that is short-term. That is not something that is usual. Long-term weather and weather patterns are going to be climate. What is typical in a specific place? That's going to be our climate, right? If people are vacationing in Corpus Christi, they could expect to wear, jeans and a t-shirt or shorts because, it's normally relatively warm. What it's like in one place at one time, that is going to be our weather. So our rainfall that changes over days would be experiencing weather. But the changes in rainfall in years would be a climate. So you notice that on these graphs that they're different. It goes up, down, up, down, up, down, right? It changes day to day. But over the years, that's showing the average amount of rain that an area might experience over decades. Now, describing weather as rain would be weather, right? Because, it can rain and then it can stop. But saying that if you have a tropical climate would be climate.